Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on September 8, 2025, about 5 days ago. The standout result is that the method boosts many-shot and context learning for tabular tasks, delivering about 15% higher accuracy than strong baselines and showing accuracy that rises steadily from 8 to 1, 0 to 4 demonstrations. The paper is titled MachineLearningLM, Continued Pre-Training Language Models on Millions of Synthetic Tabular Prediction Tasks, Scales in Context ML. And as we will see later, the implications for model training are quite significant. Beyond the gains, the approach preserves general chat abilities, reaches 75.4% on MMLU, and approaches random forest accuracy at hundreds of shots using a token-efficient prompt and synthetic tasks. Also, the authors shared a GitHub repo. You'll find a full evaluation framework for tabular MLICL, scripts for sequential and parallel pipelines, dataset links, prior data generation, single-file inference and evaluation tools, Llama factory training scripts, and demos. The SRC and scripts directories organize pre-processing, prompt generation, model prediction, and reporting. On Hugging Face, you'll find MachineLearningLM 7B weights, GGUF quantizations, quick start scripts, and evaluation pipelines, plus examples for many-shot tabular prediction and in-context ML experiments. Figure 1 illustrates why the approach matters. The prompt format, the domain gains, and the shot scaling together show reliable in-context learning for tabular prediction. The left panel presents a compact template that packs many examples and requests a single JSON array, which enables batch prediction. The top right bar chart reports large accuracy lifts at 512 shots across varied domains. The bottom right curve shows accuracy that rises steadily with more demonstrations, so performance improves rather than plateauing. So the table contrasts model families by 4 abilities, and it signals that MachineLearningLM uniquely checks all boxes. In-context learning means the model learns from many demonstrations at inference, while robust numerical modeling means it handles numbers reliably across tabular inputs. Traditional trees excel at numbers but lack in context learning and general knowledge. Tab LLM adds knowledge but struggles with numbers. General LLMs bring knowledge and multimodal inputs, yet they miss consistent numerical strength. So Figure 2 shows how the synthetic training tasks are distributed across feature counts and shot counts, which signals where the model practices most. A heat map means darker cells indicate more tasks in that bin. The grid concentrates mass around mid-feature ranges and mid to high shots, so the corpus stresses many shot contexts while still covering small settings. This balance matters because coverage across bins supports stable scaling without starving rare regimes. So Table 2 quantifies the gains. Accuracy climbs with more shots, and the proposed model leads the in-context group at every setting. Many-shot in-context learning means the model learns from lots of demonstrations during inference without updating parameters. Compared with GPT-5 Mini and O3 Mini, accuracy stays several points higher, which matters because high-shot regimes often stall for vanilla systems. The non-in-context baselines rise too, yet they trail the best in-context results by a wide margin. Alright, 2 takeaways stand out. Continued pre-training on millions of synthetic structural causal model tasks makes many-shot in context learning actually scale, and a token-efficient tabular format delivers big accuracy gains while keeping general chat skills intact. The broader implication is simple. Synthetic curricula can unlock practical, data-centric scaling for in-context learning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.